a welcome to Len Neist, so Chief Engineer with the Public Transport Victoria since May 2016. And so Len comes to us tonight. He's going to be speaking on how core systems engineering and asset engineering principles are being adopted to assure asset integrity for public transport. Len's background: he's currently an executive and experienced systems engineer. He's extensive experience in facilitating and understanding the risks associated with change and putting effective management strategies in place. Len has experience in training in enterprise and strategic risk management, integrated logistics support, safety systems, safety management systems, maturity assessment, aerospace management, systems analysis and definition, major incident investigation, and executive coaching, to name a few. So, Len, welcome. Thank you very much. Over to you.
Thank you. Thank you and good evening. As you can tell, I've had a pretty diverse background in my career, but the one common theme across that whole career has been getting requirements understood, getting requirements documented properly, and then understanding the risk of everyone trying to change those requirements once you thought you had a baseline established. So what I'm trying to do right now for Public Transport Victoria is put in place, using system engineering principles, a capability where we can define and control the change and the definition of requirements.
Can everyone mute their microphone, please? Because we're getting a bad echo here, thank you. I think Sydney's got their mic on, so if you just make sure you just put everything on mute, unless you get asking questions, that'd be great, thank you.
Try and phone again.
That's I'm used to people trying to talk over the top of me.
Just find out if they're proceeding. Yeah, I think it would be starting around.
So just moving on. It's important to define a few things. So what do I mean by asset integrity? I don't mean asset management, strategic asset planning, whole of ownership. What I mean by asset integrity is defining the things that are critical to the public transport system that ensure that everything is fit for purpose, that it's safe, that it's secure, that it's reliable, maintainable, and that it's effective in its operation. That's what I mean by asset integrity. So the role that PTV has as the network authority under the Transport Integration Act is to make sure that, one, the transport system operates on a daily basis and delivers the service plan, but two, when all these major projects that are coming along, such as the new tunnels and stations, or the level crossing removals, or the SkyRail, or anything else that's coming along, when that's introduced into the current operating public transport network, they don't screw it up. Because there's nothing worse than your public transport system not delivering, moving the people every day, every morning. So how many people here use public transport? Right. So you'd all be pissed off if the system shut down, like it did a few weeks ago. The main aim of using the system engineering principles is to make sure that doesn't happen, at least within predictable analysis. So looking at the infrastructure assets, making sure they're designed, installed and integrated. That integrated word is such a misused word. A lot of people get their requirements, you give it to a project director, they head down, they've got a budget, they've got a schedule, they've got their requirements and off they go. Problem in the public transport system is it's never one single project happening at any one time. There's lots of multiple things. There's a lot of projects happening to the extent current operating network. There's a lot of big projects coming in, a lot of big infrastructure projects. And then there's a lot of things, VicTrack, who are the asset owners of all the public transport assets, they also have projects running. Now, unless they're integrated in some collective way and you understand what all those interfaces are and you can manage all those interfaces, your risks get blown out of the water because someone's going to get left behind in a turnover of a technology, or someone's going to change or keep an older technology operating a little bit longer than they should have, whereas your project's anticipating that'll be long gone by the time my project's delivered. Guess what? It's not. It's still operating. So trying to get all that integrated and all those interfaces understood is critical to the public transport. So what do we need to do that? Why? It's so, as I said, so we can get that fitness for purpose, so that it's safe, so that all the risks have been eliminated or reduced so far as is reasonably practical in all modes of operation. By all modes of operation, I don't mean just your daily operations, because the highest risk and the worst scenarios as far as the public transport system goes, and the biggest risk to your passengers or to the public, is in degraded mode, when things are not operating as they are expected and you've got to do workarounds, you've got to change things. Engineers have to make decisions at the moment to keep the network operating, but in a degraded mode. So making sure that the risk's been eliminated or managed so far as is reasonably practical in all modes of operation is critical to ensuring asset integrity. And making sure that it's also been reduced in all support situations. So there's one thing to bring in a brand new system, you delivered a wonderful project, you hand it over to the public transport network and they take it onto the system, but they can't sustain it, they can't maintain it, they can't ensure the operational reliability, and all of a sudden the performance dropped down, and so they'll start making changes to a system that they shouldn't be touching because it's still in its infancy. So making sure that all the support situations are also considered in integrating those new capabilities into the extant public transport network are quite important. And the end result is that you've got a trusted configuration, that it's secure and dependable, it's design assured, and it's change managed. Change managed is a very critical thing in any technical system. Nothing worse than going out and deciding you're going to modify, you've got a fleet of, say, 30 trains, you're going to go out and modify the fleet, and you realise you've actually got 30 trains, you've got 22 variants. That causes a very complicated project to be unfolded. And so it's also about affordability, minimising that total cost of ownership. And the way you do that is making sure that you're on top of your requirements, on top of your change management, and that you're only implementing change because you need it, not because it looks attractive or it's desirable or because someone sold you a new shiny toy that you don't really need. This little diagram talks about requirements, definition and change management, and they're the two most critical elements of a project assurance. I'm not sure it's probably too readable from the back, but it's just going through the fact that when you're under system design, the actual design authority is the original equipment manufacturer. When it starts coming into operating service and it's in service, guess what? The design authority should still be the original equipment manufacturer because you're in the infancy of the design. You're still managing it. You're still bringing it in. You're still operating it. It's not until you get to the point where you start to modify it, not modify it using the OEM, because the OEM has lost interest in that product now. They're moved on to newer, shinier things, but you're still operating a system that's been around for quite a few years. You start to modify it using a third-party supplier or your own internal engineering.
So when I do this,
once you've made that decision, you've now moved and changed the design authority from the original equipment manufacturer to you. You become the design authority. You become accountable for the impact of any change that you put into that configuration on its technical integrity and its safety, its security and its reliability. So there's always that critical point you've got to remember before you say, oh, what the heck, we shouldn't have to go back to this supplier, they're too expensive or they're not focused on it, we'll do it ourselves. There's a lot of ramifications to that decision of saying we'll do it ourselves.
So I'm hearing something.
So in order to assure the asset integrity, you need to make sure that it's well defined and that there's a mature structure for that. So what this picture is showing is all the different interfaces. Public transport network sits in the centre there, but when you want to change something in that centre that refers to public transport network, you've got to consider every one of these fundamental inputs into that transport operational capability. Because if you don't consider every one of them, then one of them's going to get you in the end. One of them, you'll miss an interface, you'll miss a critical requirement that has been neglected and has been changed. You haven't brought your baseline up to date. And that's why I started looking at system engineering. If you look at this sort of fundamental input into your capability, your transport capability, there's a lot of systems there. And they're not simple systems. Each one of those is a system of systems in their own right. So I consider in system engineering speak that I'm familiar with, that the public transport network is a federated system of systems. So when I look at that, the acronyms that are up there, so there's under the public transport network, we've got the ferries, we've got the regional bus network, the metropolitan bus network, the metropolitan rail network, the regional rail network, the road systems, and as you can see, the regional rail network and the metropolitan rail network have a connections to roads because people get to the train stations either via bus or by car. So there's an interface in having an integrated transport capability. The metropolitan tram network down the bottom, it certainly interfaces to the roads. If you've used the tram system in Melbourne, you realise that it interfaces with the roads very critically every day. And same with the bus networks and even the ferry networks connected to the bus networks. So when we talk about managing the change to the public transport network, I have to consider each one of those systems of systems in a federated, complex way to make sure I've addressed all the interfaces, and that when someone's proposing a change to that network, that I can make sure that I've got all the capability requirements defined. We've produced an assurance plan as to how we're going to assure the change will not impact on the daily operation of the transport network, and then we've got all the different interfaces well understood, and the risks to those interfaces also understood. So if that wasn't complex enough, here's another more complex picture showing some more interfaces. So if you look over to the right-hand centre, we've got the MRN. That's the Metropolitan Rail Network, which is one of those pictures on that federation. So this is now the Metropolitan Rail Network, and these are the interfaces you would have to consider if you were doing something like the new tunnels and stations. If you're going to do the new tunnels and stations, you've got to have all those different systems that affect tunnels and stations. They all interface to the new train, the high-capacity metro train, which has all those interfaces to the other parts of the elements, the driver systems, the wheel rail interface, the traction power systems. The Metropolitan Rail Network then goes up into network rail safety and the enabling works. So this is the system of systems evolves just around the Metropolitan Rail Network. And that's not the whole thing. If I tried to put the whole system for the Metropolitan Rail Network on one slide, you wouldn't be able to read any of it. And I've got one of these for each one of those federated networks in the previous slide. So, the public transport network is a complex operational capability. Hence the need to look at something like system engineering so that I've got a basis for putting my hand on my heart and saying that the asset integrity is assured for the public transport, that it is safe and it is secure, that it will be reliable, it can be maintained to ensure that the day-to-day operations of public transport works. So along the bottom there is just your standard typical life cycle, needs analysis, requirements definition, acquisition, in-service, disposal. Thinking through those, that should be familiar to anyone who's familiar with system engineering. You look at a defence environment, a mining environment, a power distribution environment, they all have the same life cycle elements. And so we're starting to look at the public transport network and the changes to the public transport network in this context and managing the requirements under that context. Thanks. So starting to do that, we've started defining a couple of document sets that we need to get a control over and get to drive through the whole public transport system and through all the project delivery authorities that are doing work for the public transport system. And the three key documents that we're working on at the moment is an operational concept document, and that's taking the need as defined by the government and the economic policies that drive the growth of Victoria. It's taking the transport planning needs that are identified by Transport Victoria as to what the future states of the public transport might look like based on population growth, demographic distribution, where's the new university going to go, where the new school is going to go, where do we need public transport to feed those systems. They all feed into the operational concept document. And we're going to produce one of those for each one of the corridors on the Metropolitan Rail Network, for each one of the routes on the tram networks, and then get work through the bus networks and everything else. It'll take a while, but we'll eventually have an operational concept document for each one of those elements. Accompanying the operational concept document is the client requirements document. And the client requirements document is basically taking these operational needs and reflecting them into functional and performance requirements. So what is it about a specific corridor on the rail corridor or the tram network, a specific route, that we need to define so that if someone's coming in to modify it, they know what's there now, what we're willing to tolerate in change on that network, and what it is we expect to see in the way of interface management and safety levels, safety targets, reliability targets, and the future operational state needed for that particular corridor. That all feeds into the client requirements document. And then the integrity assurance plan, which my area and PTV specifically manages and owns, will define what it is we expect to see in assurance plans by either a project delivery authority or a franchise operator or anyone else who's going to be responsible for delivery and management of the change. How do we expect them to give us assurance arguments against the client requirements document and then tied back to the operational concept document, so that we can define the benefits that we expect to achieve and that we have an assurance plan to somehow give an argument that we have achieved those benefits, or we may not be able to achieve those benefits, so that we can inform back up the food chain, back up to the government saying, look, you know, that was a worthy goal, but given the state of technology, given the price of eggs in China, we're not going to be able to deliver that particular benefit to the network. However, we'll be able to deliver an alternate benefit. These three key documents will help to inform those discussions. Thanks. A little bit more detail about the client requirements document, because it is a key document. So the main things in the contents of that are, what does the current network look like? What is the description of the technical requirements that define the current infrastructure, the current operational parameters, and the current services that are delivered by that? What are the interdependencies and the interfaces? What are the project objectives? So for MMRA, if we just take the PPP for the tunnels and stations, what are the project objectives of the tunnels and stations PPP, and how does that feed back into the client requirements document for the overall Metro Tunnels project? So there's a CRD that sits at the highest level for the Metro Tunnels project, and then we need to tie back each of those individual project elements back into that CRD. What are the individual stakeholder requirements that need to be satisfied? So whilst PTV is the manager and we sponsor and we drive the CRD, we don't own the CRD. Transport for Victoria owns the CRD as a client for the delivery of those requirements. And so a lot of the stakeholder requirements are not just about the technology or the infrastructure, they're about the customer requirements, they're about the DDA, the Disability Act compliance, they're about the expected operating performance that Transport for Victoria wants to get out of the public transport network by, say, 2020, 2028. All that feeds into the CRD. And then what are the implementation constraints? So these is where the technical requirements come in. So it's a 1500 volt traction power system in the Metropolitan Rail Network. So don't bring in a plan to bring in a 22,000 volt AC train network, because it's just not going to work in the public transport network. If you're going to do that, we need to have to understand all the interfaces and what would have to change to make that happen. So there's the technical requirements, or the implementation constraints, are what is in the current public transport network that you have to be compliant with. You have to interface with it, you have to operate under those scenarios. And then what are some of the transport capability enablers that are required to happen to make sure it all comes together properly and all pulled into position. Another good unreadable document. It's even unreadable on the screen, I think. But what it's showing is, in the top left hand is the CRD. Top right hand is the assurance plan. They then feed into the project world. The next layer down in that top box is the project world. So sitting directly under the CRD, there's a systems requirement specification. So we expect a project delivery authority that's going out to market to define its set of requirements it wants to go to market with, to take the CRD and then put a lot more detail into it, because the CRD is pretty high level, and build its systems requirement specification, and then provide us with a systems assurance management plan, the document on the right-hand side there, systems assurance management plan that basically shows us how they're mapping back to the CRD and how that assurance management plan is mapping back to that assurance plan at the top right-hand, to prove that they're going to satisfy it and provide the assurance arguments that we expect, so that we can release it into revenue service at some time. That all then feeds down into the contracted document and the arguments behind and the contracted agreements in that centre. So you've picked yourself a supplier, you've taken your SRS, you've got some bidders, they've agreed to it, you got your preferred, you're going out to market and you're going to go deliver something. Once it's been delivered, you've got a system design and you have an organisation and a project assurance capability, that all has to flow back up to that CID and that assurance plan. We have to have that traceability all the way up before it can be accepted back into a revenue service, because that's the only way we can assure the safety, the security, the reliability of the public transport network, if we've got traceability all the way back up to that original CRD and that original assurance plan. And that's why we're starting to use these system engineering processes to do this. That's just another view of the same thing, and it's basically starting with an operational concept and working all the way down to the operational evaluation and back up to a systems assurance and acceptance into service over on the right-hand side. So it's just another view of the same, but that previous view was looking at it from a public transport. These are the documents we're starting to shape and you think when we're starting to think in a systems framework. This is your traditional system engineering framework for taking your needs analysis into your functional performance specs, into your contract specification, and feeding it up into your assurance back into operational service. And so we're starting to use this level of thinking and maturity across the public transport network requirements. So the question which I'm trying to answer all the way along, so why have I turned to system engineering to help? So if you look at this pretty picture, it's showing you things like executive leadership and accountability, and that's talking about capability definition and management systems, workforce, contractors up the top left hand in the bluish colour. You then have some risk management, and you have some change management, and you have some asset management. All of these are nice little stories in their own right. You can go and talk to risk management specialists or change management specialists or asset management specialists. And then the final bit is operations and bringing it into service and interfacing with other operations depending on their capability and their safety management systems. So the asset integrity relies on effective integration of many disciplines, something that system engineering is familiar with, but as always, the risk is at the interface. So once again, like I did in the beginning, if I take just one of those little elements, the risk management bit, this is how I view risk management. So when I view risk management, I'm looking at what is the objective, what is the problem. I go down into preventive controls and protective controls. I look at contributing factors and plans. I look at escalation factors. I look at probabilities. I look at consequence. What are some of the escalation factors that cause the probabilities to escalate or risk, so that you can work out your target. So just again, and up the top, you've got all these different mechanisms and these different inputs and escalation agents, because sometimes your risk is not by accident, it's being enforced upon you by other entities or whether it's a risk for opportunity or a risk for threat or hazard. There are other agents that will enforce that upon your operating system, and you have to accommodate that. So that's just your risk management plan. So again, as with the previous example, if you do one of these for each one of those previous boxes, you end up with a very messy concept, and you've got to be able to integrate that. And then, as I said, I've done that. So looking at all the various interfaces between all those different philosophies, such as asset management, configuration management, risk management, there's a whole bunch of interfaces on the fly that you have to consider at every stage of your project definition, your requirements definition, your assurance planning, your design definition, your verification, your validation, and your assurance argument for acceptance and service. You should be looking across all these interfaces, looking at all these different capabilities in an integrated fashion, and system engineering helps us do that. So at PTV, this is just an org chart of where we're heading. So we've set up a entity called the Network Integration and Project Assurance team within PTV, and as that implies, it's responsible for the technical services, which is over the left. So under technical services, I have a lead asset engineer, I have a lead systems engineer, there's going to be a network to technical performance engineer. Those three capabilities together will help us define the requirements, manage the assurance, and then working towards all the different project delivery authorities and reviewing their arguments, helping to educate them in system engineering practice, helping to define all the interfaces, making sure the interfaces are considered. The second from the left is the Director Project Assurance, and as their name implies, they're the interface to the projects, so to MMRA or to LXRA, to the direct projects. There's a project assurance team that we're interfacing to them, making sure they understand the need for the CRD, that the CRDs are being developed in the right way, that the assurance plans are being developed so that we can bring it all back together and test it and assure it and bring it back into service. There's a project delivery arm within that NIPA area, and that's for the projects that PTV is the accountable body for project delivery. Asset management is talking about the strategic asset management of the public transport network, as opposed to just asset integrity. So that's the whole of life strategic asset planning. And then there's support office. So PTV, on the back of systems engineering thinking as planning, is starting to produce this organisation that its focus is assurance of requirements, assurance of change, and then acceptance of arguments to bring that change into the public transport network. So part of that, we've set up this wonderful entity, and the acronym's in the middle there, NACAC, really good acronym. It's, the inventor of that acronym is sitting in the front here, Paul, so you can have a chat to Paul about it later. But NACAC is such a brilliant acronym. Why is it so brilliant? Because people have adopted it. It's easy to say, and sometimes they don't even ask what it means. But sometimes you need that. Sometimes you think you need people not to ask what it's about, but just got on board with it and listen to it as it evolves and develops. And that's what's happening. So NACAC now has become a significant asset change and assurance committee. So anything that's a significant change to the public transport network has to pass through NACAC to get those changes endorsed. Or to advise NACAC that, you know, that business opportunity or that development that you're expecting to deliver by 2028, it's not going to be delivered. It's just not going to happen. That goes through NACAC and then gets fed up to the government to inform that you need to change your goals or your objectives. So supporting the NACAC on either side, there's a network operations working group, and as the name implies, their focus is on modelling, simulation, testing, and doing the impact analysis of change on the operations of the public transport network. So they come up with the stage gates. So if we want to move X number of people across X corridors within an hour in the morning peak by, say, 2022, that will come through that network operations working group. They'll test it. They'll test the impact of that on the current infrastructure, and plus when there's infrastructure changes coming, they'll test via modelling and simulation what impact that would have on achieving those operational outcomes and goals. The other side of the coin's the Network Integrity Working Group, which I chair, and that's about the physical infrastructure and the assets. So what is the impact of change on the assets? Is that change acceptable? Can we endorse it? Can we tolerate it in the public transport, or will it create so much risk that we need to send them back to the drawing board to rethink what they're delivering or what they're changing? Those two bodies working together then support propositions and arguments that go up to NACAC for endorsement. And then that then flows up into the Transport Executive and the other various relevant committees around public transport in Victoria. So this is why NACAC was established. So it's a forum to bring senior level cross-departmental stakeholders together for timely decision making. That's a wonderful statement. Try doing it. It's like herding cats, because they're all very busy. They all have very important decisions to make, and and I'm not being cynical or anything, they really do have important decisions to make. So trying to get 15 minutes of their attention to help you make a decision on something that's going to happen 5 years from now that will affect the public transport network is really hard. NACAC is helping to make that happen by using this systems thinking framework to bring people together to look at the asset configuration and assurance of the public transport network and the impact of changes on those assets. It's starting to make that happen. It's becoming the network assurance and change steering group. So it's looking at the risks. It's become a place to review and endorse the CRDs and the assurance plans. And it's a place to review the progress against the assurance plan. So we've set up various stage gates for NACAC. So as the projects evolve, as they move to contract signature, as they move to critical design review, to commissioning, to in-service, they have to come back to NACAC and tell us, hand on heart, we're still 100% compliant with the CRD, or we've changed these X% of your requirements. This is what they've changed to. This is how we believe they're still meeting the operational intent or not. And this is what it's going to do to the public transport network when we have to bring it into commissioning and into revenue service. That all comes through NACAC now and helps inform the assurance processes. And as always, management of change isn't simple. There's always trade-offs. So you're looking at the value that you want to achieve. You're looking at the cost. Can you afford the change? Is it practical? And the risks. So there's nothing new in there, but there's nothing new to system engineering. But thinking of all these in the context of major transport projects across a horizon of 5 to 10 years and managing the change across all the interfaces, just putting this on a piece of paper and making people focus on that in a systems framework is new, and that's where we're heading with it. So by using that systems engineering approach, PTV helps to make sure all the relevant inputs and constraints are considered. So this is not a public transport for Victoria diagram. This is a diagram I've used in defence, I've used it in investigations, I've used it everywhere. But this is why system engineering is going to help Public Transport Victoria get on top of all the change that's about to come with all these major projects that are about to bring across new operational capabilities, new ways of moving transport, new interfaces, new things new risks to consider and manage it on a day-to-day basis. Using this system engineering management framework, we can make sure that all the different aspects are considered in the development of that change process. So we've still got a way to go. NACAC's established and operating, but it's not that old. It's still pretty young. It's still evolving. We're still getting to people to understand what it's about, how it's managing, but people don't ask what it means anymore. They don't ask what NACAC stands for. They just know they have to come to NACAC, explain their risk argument and get it endorsed before they can move on to the next stage of their project. And that's a good thing. CRDs and the network assurance plans have been accepted. They've been taken on as an essential requirement for a business case approval. So the entity that approves future business cases for new projects in the transport environment, their first question is, have you got a CRD? Do you have an NIAP? Has it been endorsed through NACAC? That's a critical step in bringing everyone's attention to the system engineering framework. And we're working on preferred solution for modelling and support. So the modelling and support is evolving and changing. We're working on how to best get that down so we can build the architectures, the system architectures a little bit stronger and a little bit more hands-on. And we're looking at the best tool set for representing the hazards, the threats, the opportunities. So we have tools that we use now for the opportunities and the assumptions, the dependencies, but they're not as integrated and not as systems focused as I personally like them to be. So we're going to evolve them a little bit more as well. That's the end of the story. Any questions?
Hi Len, thanks for that. I'm glad to hear that systems engineering's been taken into other areas. Working in defence for the past 2 years, I'm now working in a rigorous systems engineering environment. Previously in mining and metals, not so much. So from your experience, okay, you've got the NACAC, which I see as the configuration control board. Now, the Network Operations Working Group, what kind of stakeholders do you have there? And you said modelling simulations. Are they building functional flow block diagrams? Is that the potential suppliers that are simulating those models, or?
No, it's an internal capability, and it's made up of the transport planning functions and the people who understand the operations of the network. So they're building operational simulations of the entire public transport network, so that when we are changing the throughput on a particular corridor or a particular interface between tram and train, we can actually model it and assess the impact and start testing those scenarios. Because a timetable takes quite a long time to develop, so if you're changing the infrastructure and the population is growing all at the same time, you've got to make sure that by 2026 that all comes together in an operational fashion. And that's the purpose of the operational working group and their modelling.
So are they in essence taking the operational concept document and then decomposing it into functional performance requirements for subsystems? Is that what they're doing?
No. That's the role PTV plays mostly in creating the CRD, in decomposing the transport capabilities and operational needs into the network requirements. They are developing the operational side of those requirements, though. So they are functional and performant, but not in terms of infrastructure and assets, but more in terms of the throughput and operations of the public transport network.
So the higher level requirements. So you mentioned doors. Do you have a baseline or a semi-mature baseline in doors?
I didn't mention doors.
I thought I heard you mention doors. Sorry. I thought I heard you mention doors, sorry.
Okay.
Must have misheard, yeah.
I don't think I recall mentioning doors as a requirement, but we do use doors, but the problem right now is multiple different entities using multiple different elements of doors, so the goal is to bring all that together in a unique operating environment for transport.
Yeah. Excellent.
Are there any questions from Brisbane? I'll come to hear Melbourne shortly. Yep. Edmund?
Yeah, one question, just a sec. Yeah, just how do you go in terms of normalising all your acronyms and getting people understanding pain points between different transport systems?
Well, if you're involved in public transport in Victoria, you understand all those acronyms. Remember, I'm the customer inside. If you need to learn them to sell me stuff, go and learn the acronyms.
Quack in South Australia, any questions?
Yes, I got one. In relation to the brownfield development, of course there are existing lines on the network, and knowing that more lines will be added, which means the brownfield development, in terms of how system engineering and architecture can help with the overarching insertion of capability and ensuring the interoperability and integration aspect of that, how do you envisage that to occur at the top level to govern the insertion of incremental capability for the transport network?
Yeah, that's why I said one of the elements we're still working on evolving are the network architectures. And that's the intention of those architectures, is to get a strong definition of the current network as it exists, and then as planned change comes about, we can then test it on those architectures. Okay.
Is it the intention that that will be available to the wider industry?
No. When you say made available, we're not going to publish the public transport network architectures because we're using it as our own internal tool set. If you're involved in a project that has to interface or relate to that, then yes, you'll have access to those architectures. And they'll be used as part of developing in union with all the stakeholders, including the project delivery authorities, the CRDs and the assurance plans.
Great, thanks for that. One more question from Adelaide. Go ahead.
Just a quick overall one. You mentioned that people know they have to come to NACAC as a hurdle to overcome, but they might not necessarily even know what NACAC is or what it means. How do you go about driving a cultural change in adopting systems engineering now flowing on through from the top down?
Yes, yeah, we're working on that. We're using both the acronyms and the tool sets, but every time we have a meeting to explain to a particular project why they actually need to be interested in coming to NACAC, we sell system engineering and we sell the philosophies behind it, and we bring them along for the ride. So we're trying to, that's what we're using system engineering or systems thinking to do, is to bring about that cultural change so that we're managing the requirements and the risk and the change to those requirements in a systematic, definable way.
Thank you.
Just a show of hands in Melbourne, if any questions. I know there's at least 5, so I'll rove the floor. Do we have Sydney online with any questions? No? Okay, so Len, I'll just rove the floor for a second.
ACC?
Now, later on, when you're answering the questions, talking about the network being the whole system.
The network, in the beginning slides, I depicted the public transport network as the whole whole system.
Yes.
I then narrowed that down to the Metropolitan Rail Network,
Yep.
which can then be narrowed down to a single corridor on the Metropolitan Rail Network.
Okay, so my question then becomes, from the PTV's point of view, how do you sell that to your the suppliers that are supplying to you? Because all they do is supply within one of the stovepipes. It's only PTV that gets to see the whole system, not the stovepipes themselves.
So PTV doesn't sell anything to any supplier. PTV is the network architect, so we need to define and manage the change to the network. The franchise operators, such as Metro Trains or Yarra Trams, they're the ones who buy from suppliers to maintain or to bring new systems in, or the major project delivery authorities such as MRA or LXRA are buying systems that they're bringing in and changing the network. So they need to make sure that those systems, equipment, technologies, processes that they're bringing in, if they're already defined and already been certified in an operating system and the operators are willing to bring them in, that's fine. But if they're brand new, greenfield, leading edge technologies, then they need to bring an assurance argument with it that defines why PTV should accept that onto the public transport network.
Maybe I'm not stating the question. For example, we've got this new project called SkyRail, as an example. It interfaces with a number of buses and train systems, and it appears as though those interfaces are not going to work. Now, I would assume that that's the role of PTV. Those
particular interfaces will have to be tested through the Network Operations Working Group.
Well,
so that's the point of that testing, is to find out. And if they're not working, that then has to flow back up into Transport for Victoria so that they can plan and work out what they need to do. Every project's not funded to do absolutely everything that makes a change on the day, but where we can identify the deficiencies and the risks, they have to be fed up through the department to bring in additional change if required.
Len, Sean Wilson from Shoal Engineering, thank you for a very illuminating presentation. Question about to what extent are you and how are you and what reaction are you getting in selling the concept upwards to PTV senior management and even to the political level of government?
PTV, we've got excellent buy-in from PTV senior management all the way through the chief executive. And the creation of NACAC, when we first created it, I was chairing it and we were just starting to market and sell it. It's now been endorsed by the Transport Executive all the way up to the Secretary of the Department. And they've, as I said, that now sits across all their processes in their procurement and their business planning, so that they'll ask someone who's come up with a business case for a new capability, they will ask, have you got a draft CRD? Have you got an assurance plan? Is it being considered and socialised with NACAC? So we've got buy-in all the way up through the department.
G'day, Len. With the adoption of systems engineering approaches here in Victoria, what consideration is being given to systems engineering approaches that have been developed in other states, most notably with Transport for New South Wales as one example?
Yeah, I'm pretty well connected with Transport for New South Wales, having been their regulator for 5 years, so I know all the guys up there pretty well, and they still answer my calls. So I talk to Jim Montravanis quite a bit, and I know Graham Jackson and all those guys quite well. So we attended Incosi. We had a lot of discussions with Transport for New South Wales guys at Incosi in South Australia. So we're working together on a lot of things.
A quick check interstate. Are the questions coming through clearly? So Edmund, clock.
Coming through loud and clear from Adelaide.
Yep. Thanks very much. Next question from Melbourne, and then we'll cross to Canberra.
Nice. I think we all agree the top-down approach works well when you are looking from the top down. How do you see market-led proposals going into this framework?
For a market-led proposal to get into this framework, the market-led proposal has to have been through the first 3 stage gates, i.e. that it's something that the government wants, it's a viable solution, and it can only be uniquely deployed by whoever's putting forward the market-led proposal. Once it reaches that point, it just becomes another project and has to go through these processes. It will have to have to move from stage 3 to stage 4. require a client requirements document, and it'll start to have to engage with the NACAC.
Thank you.
Ray, any questions from Canberra?
Yeah, hi. G'day, Len. It's BJ Martin. I was interested in how you're going with, or how you anticipate to be going with educating the traditional suppliers of infrastructure and rail with systems engineering concepts and the expectations of assurance evidence, and how they ensure that they, I guess, they plan and cost all of that in. I guess having a governance or a project governance area that tests it and tells them they got this wrong and they didn't even know they were to get it right because the requirements were a little bit wonky or they didn't own the problem, can still causes a problem via the PTV and an angst with the projects.
Thanks, BJ. I expect guys like you to do that for me. We expect the big project authorities such as LXRA and MMRA to, and I know they are doing it, it's not just we expect it blindly, to start educating some of their project teams and their suppliers of how to start bringing in these complex technologies, because it's changing from just concrete to steel to complex integrated systems that you need to deploy to get your transport capabilities operational. And so the LXRAs and the MMRAs and even to some extent some of VicTrack are starting to increase their own awareness and their own maturity of system engineering practice, because they have to do it to get the requirements understood and get the risk managed. So I think that's going to, PTV doesn't have a plan or an outward focus to go and educate all the suppliers, BJ, but it is starting to happen in that way.
Thanks.
Any closing questions here in Melbourne?
Got one more from Canberra, Len, if you've got time.
Yep, take that.
Yeah, look, it's Dave Gatt from Canberra. I've got a question about, have you found that you need to modify the system engineering process given the audience? It's kind of almost touched upon by a couple of other questions, but I'm just curious as to any changes you need to make.
The changes are not so much the process, but some of the labels. So PTV were working for quite a while to get a configuration control board established. Those words didn't make sense to a lot of people, but when we created NACAC, which someone's correctly pointed out, it's a configuration control board, it was accepted. But because they were looking at asset configuration and assurance, and it wasn't a pure system engineering or even engineering term such as configuration control, it became more accepted in their lexicon and they were. So I don't have to change. They're the same system engineering processes I've been working for since I was in defence in the early 80s. Same processes. Sometimes you just have to change the words or the labels or the diagrams to make sense in the particular operating context. And so yeah, you have to do that, but the underlying system engineering principles are the same.
Okay, thanks, Len.
Ed, to you.
Ed Gusto, I just wonder, in the operations that you run as a systems engineering process, what are the metrics that you have chosen, if you have, for the capacity of the system to be able to manage systems like change requests or change coming, how many projects, how many requirements, how many risks are being reported? Do you have any metrics or any news?
We're not quite there yet. We're still evolving and developing the systems, but we do have a radar register for all of these projects. So it's the risks, the issues, the dependencies, the assumptions, and the opportunities. So we do measure that, and we use that pretty much guiding us as to where we're going with some of these projects. But longer term, yes, you'll need, once you've got a mature operating system engineering framework in place, then you can start to measure the amount of change, the momentum of change, and the direction of change in it. But we're not there yet.
Just one last burst to the other sites. Edmund in Brisbane.
Yeah, one question.
Thank you.
Hi there, Rodney Pusey here. I was just looking at this presentation. It's quite focused on the actual, I guess, definition and procurement of the systems, but are you doing any work or involved in any working groups where you're looking at actually evolving some of the regulation and acceptance of systems?
Can you define what you mean by regulation?
Well, obviously a lot of the operators have safety management systems that they work within. Some of the safety management systems, I guess, could be considered a little bit dated when you start talking about performance-led requirements, functional requirements, and specifications. So really in that kind of area, like reducing the actual system acceptance risk.
Yeah, so what PTV is doing in that field, so the National Rail Safety Regulator in the rail environment is responsible for accrediting organisations in accordance with their presented SMS and then assuring that those SMSs are kept mature and in place and effective. PTV's role is in our understanding and our comprehension and our feeling for what is the current state of the asset and how is the integrity of that asset being managed by those accredited rail transport operators. And so that's where we'll be focusing on doing our own inspections, our own verifications, our own assurances of the current state of the public transport network assets.
Thanks. Ray, any closing questions from Canberra?
Nothing further.
Thank you. One closing question from Melbourne.
Hello there. I had a question about the interaction between standards and specifications and those high-level kind of the higher-level client requirement documents. So with the sort of less focus now on Viriogs and more standards and specifications being written by the franchisees or VicTrack or other sort of the operator level, how do you envisage tying those standards to those high-level specifications so that, or the high-level requirements, so that they are enacted when those standards are followed by people on the major projects?
So the plan is to capture the network as a set of high-level technical and operational requirements, and then the future standards will be derived from those requirement sets. So the standards will be just windows of requirements for a particular application or a particular need. It's just an instant of the requirement set. But the higher level requirements are what will define the operating networks.
So do you see PTV having a role in vetting those standards and specifications to ensure there's alignment, or do you think that's a responsibility of the franchisees to demonstrate that link, or is that a work in progress?
It's not a work in process. There is a role there. So the franchise operators and some of the other operators starting to set up engineering standards committees, which PTV participates in and as a witness to, and then under future contractual arrangements, there'll be a higher level management across those standards committees with a little bit more influence from PTV on the standards and their practices.
Brilliant. Thank you very much.
At that point, I'd draw it to a close. Would you join me in thanking Len for a really experience-based case study tonight? Thank you.